There is a mountain in southern China where no truck has ever delivered a single brick. No road leads to its summit, and no crane has ever been installed there. For most countries, such a location would mean months of delays or the destruction of the surrounding landscape simply to make construction possible. China chose a different solution. It sent drones. In just 3 days, a fleet of 16 heavy-lift drones transported 180 tons of steel, concrete, and construction equipment directly up the cliffs of Yunnan province. Not a single tree was cut down, and no road had to be built. The materials were delivered from the sky as if the mountain had never been an obstacle at all. This was not a concept or a computer-generated demonstration. It was a real power grid project completed in 2025. This achievement represents something much larger than a single construction project. It signals a major transformation in the way infrastructure is being built around the world. The idea that difficult terrain automatically means difficult construction is beginning to change. Today, drones are not only delivering packages, they are becoming powerful industrial tools capable of replacing roads, reducing environmental damage, and dramatically shortening construction timelines. Most people assume that the hardest part of building large structures is the construction itself, the steel frameworks, the concrete pouring, the wiring, or the assembly. Engineers, however, often point to a different challenge. The most difficult and expensive part of many projects is simply reaching the construction site. Imagine building a high-voltage transmission tower on top of a mountain. Before the first bolt can be tightened, hundreds of tons of materials must somehow be transported to the site. Traditionally, this involves one of several difficult options. Workers may need to cut roads through forests and mountains, a process that takes weeks, costs millions, and causes significant environmental damage. In protected areas, such projects may not even be legally permitted. Another solution is building temporary cableway systems to transport materials across steep terrain. Although effective in some situations, these systems require considerable time and resources to install and are limited in the types of loads they can carry. Helicopters are another option, but they are extremely expensive to operate, have payload limitations, and can be difficult to position accurately in dangerous environments. All of these approaches share the same fundamental problem: require enormous investments of time, money, and manpower before construction is even begun. For centuries, difficult terrain simply meant higher costs and longer delays. There appeared to be no alternative until drone technology became powerful enough to carry industrial-scale loads. Many viral videos on the internet suggest that China is using drones to lift entire tower cranes and place them on top of buildings. While these claims are visually impressive, they are inaccurate. Fully assembled tower cranes weigh tens of thousands of kilograms when their bases, counterweights, and structural components are included. No drone currently in existence can lift an entire crane into the air. The reality is even more fascinating. Instead of replacing cranes by lifting them, these drones perform many of the same tasks themselves. Construction materials are transported piece by piece through multiple flights directly to the worksite. Workers stationed on mountainsides, transmission towers, or elevated platforms receive materials precisely where they are needed without requiring traditional heavy machinery to reach the location. These machines are far more advanced than ordinary delivery drones. Some industrial models are equipped with 12 propellers arranged across 6 axes and are specifically designed for power grid construction projects. Others are unmanned coaxial helicopters that use 2 sets of rotating blades stacked above one another, enabling them to transport heavy loads even at high altitudes where thinner air significantly reduces the performance of conventional aircraft. Perhaps the most remarkable feature of these systems is their precision winch technology. Unlike consumer delivery drones that simply move packages between 2 flat surfaces, construction drones must transport heavy materials to highly specific locations. They must remain perfectly stable while lowering their payloads and ensure that nothing swings into nearby workers, electrical equipment, or surrounding terrain. This winch mechanism effectively transforms the drone into a flying crane. Instead of merely transporting materials, it can carefully lower them into position with exceptional accuracy. When an entire fleet of such machines operates continuously, mountains, cliffs, and forests cease to be barriers. They become nothing more than coordinates within a flight plan. The true value of this technology is demonstrated not through specifications or promotional videos, but through the projects it has already completed. One particularly remarkable example comes from Yunnan province in southern China. Construction teams were tasked with building high-voltage transmission towers within an area characterized by steep limestone peaks and protected rainforest. The region also serves as part of an elephant migration corridor, making environmental preservation critically important. Traditional construction methods would have required roads to be cut through protected forests or weeks of preparation to establish temporary cable transport systems. Both options would have significantly disturbed the surrounding ecosystem and substantially increased construction time. Heavy lift drones completely transformed the project. Construction materials were transported directly to otherwise inaccessible locations without damaging the landscape below. The need for temporary roads disappeared entirely, wildlife habitats remained undisturbed, and what would traditionally require weeks of preparation was completed within only a few days. This is more than an engineering success story. It offers a glimpse into the future of construction. As drone technology continues to evolve, industries around the world may begin to rethink how they approach some of their most difficult logistical challenges. In places where roads cannot be built and cranes cannot reach, the sky itself is becoming the newest pathway for progress. Over the course of 3 days, heavy-lift drones repeatedly flew into the mountains carrying steel tower components, concrete materials, and rigging equipment directly to their construction sites with remarkable precision. By the end of the operation, 180 tons of materials had been transported entirely through the air. The surrounding forest remained untouched. No temporary cable transport systems were required, and no roads had to be carved into the mountainside. Construction simply took place where it was needed, without forcing the environment to accommodate it. During a severe winter freeze in a remote region, ice had accumulated on transmission lines, creating a potentially serious threat to the electrical infrastructure. The additional weight caused by ice buildup can damage equipment and trigger widespread power outages. Repairing such problems is extremely dangerous, as workers are often required to operate near live high-voltage power lines in freezing temperatures and strong winds. For decades, these conditions have resulted in serious injuries and fatalities among maintenance crews. Rather than exposing workers to these risks, drones were deployed to handle the most dangerous aspects of the operation. One drone carried a controlled heat source capable of melting ice directly from the power lines, while another employed a suspended beam designed to physically dislodge the accumulated ice. Although the process appeared unusual, its underlying principle was simple and effective: place the machine in harm's way and keep human workers at a safe distance. What connects these 3 projects is not merely the technology itself, but the problems that the technology removes. In Yunnan province, drones eliminated the need to disturb protected natural environments. In Xinjiang, they removed the dangerous transportation of equipment across unstable terrain. In Hubei, they prevented workers from climbing toward frozen, live power lines under life-threatening conditions. These machines are not replacing every worker or every piece of construction equipment. Instead, they are targeting the most difficult, dangerous, and inefficient aspects of each task and making them disappear. This consistent pattern is far more significant than any viral video circulating online. It demonstrates why countries and industries around the world are paying increasingly close attention to the development of heavy-lift drone technology. The uncomfortable truth, however, is that the United States was not always behind in this field. In fact, America possessed advanced heavy-lift unmanned aircraft capabilities long before China's construction drones gained international attention. Understanding what happened to that technology provides valuable insight into why the 2 countries have taken such different paths. One notable example was the common K-MAX, an aircraft that began as a heavy-lift helicopter featuring an unusual intermeshing rotor design. Its 2 rotors crossed one another in an X-shaped configuration and rotated in opposite directions, allowing it to lift substantial payloads with exceptional stability. The aircraft was eventually converted into an unmanned platform and deployed by the United States Marine Corps in Afghanistan, where it successfully transported supplies to remote military outposts located in extremely difficult terrain. The technology worked exactly as intended. Its capabilities were proven under real-world conditions, demonstrating that autonomous heavy-lift aircraft could safely operate in environments where sending human personnel was dangerous. Yet, despite its success, the K-MAX never evolved into a widely adopted civilian tool. The aircraft was expensive to maintain, difficult to scale economically, and remained closely associated with military operations. Production eventually ceased after only a limited number of units were manufactured. The capability existed, demonstrated its effectiveness, and quietly disappeared without becoming part of everyday infrastructure development. China pursued an entirely different strategy. Rather than focusing on a small number of highly specialized and expensive aircraft designed for exceptional circumstances, Chinese manufacturers invested in developing smaller heavy-lift drones for repeated civilian applications, particularly across the country's expanding power grid network. Their objective was not to create a single impressive machine, but to establish an entire category of industrial tools capable of solving practical problems every day. By continuously deploying drones across real construction and maintenance projects, industries gained experience, confidence, and increasing demand for the technology. One country built an extraordinary machine, while the other built an ecosystem and a market around its practical use. That distinction has proven enormously important. Regulatory approaches further widen the gap. In the United States, operating large commercial drones over populated areas or critical infrastructure involves navigating complex approval processes that can take considerable time. Large unmanned aircraft often do not fit neatly within existing commercial drone regulations. Operations conducted beyond a pilot's direct line of sight typically require special authorization and additional safety considerations. These regulations exist for important reasons. Heavy machines operating above people and infrastructure present genuine safety risks, and regulatory oversight helps ensure that those risks are managed responsibly. However, lengthy approval processes can also make it more difficult for companies to gain practical experience with emerging technologies. Limited operational experience discourages investment. Reduced investment slows technological development, and slower development limits the growth of the broader market. China approached the same challenges from a different perspective, emphasizing large-scale civilian deployment and continuous industrial adoption. The result is not simply a technological difference. It is a difference in how innovation moves from laboratories into the real world. China has approached the development of drone technology from a fundamentally different direction. Rather than treating drone operations as isolated regulatory challenges that must be approved on a case-by-case basis, it has begun building drone airspace as an integral layer of national infrastructure. Licensing systems, flight corridors, city planning, and industrial projects are increasingly being designed together to support large-scale drone operations. The city of Shenzhen already operates dedicated drone logistics corridors as part of its transportation network, while other Chinese cities are planning physical spaces for drone activities, much like previous generations designed roads, bridges, and parking facilities. The message being sent to manufacturers is straightforward. Continue building the machines because the surrounding system is being intentionally developed to support them. In contrast, a drone company in the United States may possess highly advanced technology and still spend years securing regulatory approvals, arranging insurance requirements, finding customers willing to adopt the technology, and identifying locations capable of supporting its operations. The machine itself is only one piece of the challenge. Often, the more difficult obstacle is building the regulatory and operational framework that allows the technology to function effectively. This is not a minor difference between two countries. It represents a structural distinction in how emerging industries are being developed and supported. When we step back and look at the broader picture, an even more significant transformation begins to emerge. Construction has historically followed a simple sequence. First, access must be created, and only then can construction begin. Access requires roads, staging areas, cable transport systems, fuel depots, machinery tracks, and cleared ground long before the first structural component is ever installed. This initial phase is expensive, time-consuming, and frequently causes environmental disruption. Yet it has become so commonplace that most people rarely think about it. Heavy-lift drones challenge this traditional model directly. If construction materials can simply fly to their destination, a substantial portion of the preparation process disappears entirely. Roads become unnecessary, cable systems are eliminated, and weeks of ground preparation may no longer be required. Construction can begin immediately at the actual project site rather than several kilometers away at a staging area. This seemingly simple change dramatically alters the economics of projects that were once considered too expensive or too difficult to pursue. A transmission tower on a remote mountain that previously cost several times more because of accessibility challenges can now be approached differently. Power infrastructure planned through protected wetlands may no longer require extensive environmental disruption. Emergency repairs that once took days to reach may instead be completed within hours. These possibilities are not theoretical or futuristic concepts. They are already being demonstrated in real-world projects, and the technology remains in its relatively early stages of development. Heavy-lift drones still face important limitations. Battery technology restricts flight duration. Strong winds can transform precision operations into hazardous situations, and high-altitude environments reduce the amount of weight that drones can safely transport. A drone capable of carrying 100 kilograms is not equivalent to a crane lifting an entire structural module. Nevertheless, the overall direction of the technology is increasingly clear. These machines do not need to replace every crane, road, or construction vehicle to transform the industry. They only need to eliminate accessibility barriers in projects where those barriers represent the greatest cost and difficulty. Once that capability becomes reliable and routine, the economics of construction in difficult environments changes permanently. There is also another dimension to this conversation that often remains quietly in the background. A machine capable of transporting construction materials with precision into remote mountain locations could theoretically transport other types of payloads into similarly challenging terrain. The same navigation systems used to guide drones toward construction sites may be adaptable for entirely different objectives. Because of this dual-use potential, Chinese drone platforms have faced increasing scrutiny and restrictions within the United States and Europe. However, such restrictions introduce their own challenges. Limiting access to affordable and highly capable foreign technologies is only effective when viable domestic alternatives are prepared to fill the resulting gap. At present, those alternatives remain under development in many parts of the world. Policy decisions alone cannot immediately replace years of technological experience, industrial investment, and market development. China's construction drone initiative remains in its early stages, and significant challenges still need to be addressed. Yet the broader pattern has become increasingly apparent. The technology is proving itself first by solving problems that humans find most difficult. The dangerous climbs, remote supply deliveries, and environments where terrain itself becomes the greatest obstacle. Rather than attempting to replace every aspect of construction simultaneously, drones are making the most difficult parts of specific tasks safer, faster, and more efficient. As confidence in the technology grows, manufacturers produce more specialized machines. Infrastructure projects are increasingly designed with drone operations in mind, and construction plans that were once dismissed as impractical are reconsidered with entirely new economic calculations. Gradually, the construction industry begins reorganizing itself around what has become possible from the air. China currently possesses a significant advantage in this developmental cycle, not because the technology itself is magical or unattainable, but because the systems surrounding it, including regulatory approvals, flight corridors, industrial demand, and repeated real-world implementation, are being developed deliberately and rapidly. The viral images of drones carrying construction materials into the mountains are not the most important part of this story. The real story is that for a growing number of difficult construction projects, the first machine to arrive at the worksite is no longer a truck or a crane. Increasingly, it is a drone. The United States continues to possess extraordinary engineering talent, substantial investment capital, and a powerful industrial foundation capable of competing in this field. Projects such as the K-MAX demonstrated long ago that the technological capability itself was never beyond reach. The more important question is whether regulatory systems, market structures, and industrial development can evolve quickly enough to close the gap before drone-based construction becomes an established global standard. The next revolution in construction will likely not involve enormous swarms of giant drones carrying skyscrapers through the sky. It will probably appear much quieter and more practical. It may look like a drone lowering a steel component onto a mountain ledge, transporting critical tools across a dangerous river in less than 30 minutes, removing ice from a power line before any worker is required to climb toward it, or transforming a remote construction site that once required weeks of preparation into a location accessible through nothing more than a carefully planned flight path and a precision winch system. That is the future China is learning to make routine. The rest of the world is now watching closely to determine whether it can develop the technologies, systems, and industries necessary to follow the same path.